So today we are going to be talking about geometric sequences. And geometric sequences are a sequence in which the ratio between terms is constant. Now, if you remember yesterday, we had an arithmetic sequence, and we said that meant we were adding the same thing over and over again, or subtracting the same thing over and over again, because that's just adding a negative. But geometric sequences are when the ratio between terms is constant. That means if we divide consecutive terms, ratio, if we divide consecutive terms, we always get the same number. So that means that we're actually multiplying by the same thing over and over again. All right, so we can be multiplying by a whole number, so the numbers are getting bigger. We could be multiplying by a fraction. So, the numbers could be getting smaller and it's still a geometric sequence. But the key is, the pattern is we're multiplying by the same thing every single time. Now, just like what we were adding was called the common difference yesterday, what we're multiplying by is called the common ratio. Right? So geometric sequence is a sequence in which the ratio between terms is constant. We're multiplying by the same thing each time, and you might want to make a note of that. We're multiplying by the same thing. And it can be a whole number, it can be a fraction, but we're multiplying by the same thing every time. And we call that same thing that we're multiplying by the common ratio. All right, so determine if this sequence is geometric. If it is, find the common ratio. So the first one. So let's take a look. We've got 5 to 15. What would we multiply by there? 3. So to get from 15 to 45, well, 15 times 3 is 45. What is 45 times 3? Oh, that is 135. So we have actually...
Mr. Rudd, call 4003, please. Mr. Rudd, 4003.
We've multiplied by the same thing each time. So yes, it is geometric. And since it is geometric, we need to find that common ratio. R is the variable we use for the common ratio, and the common ratio is 3. So let's look at another example. All right, so 15 to 30. To get from 15 to 30, I could multiply by 2. But to get from 30 to 45, I don't multiply by anything. Actually, 15 plus 15 is 30. So we're not even multiplying at all. I'm adding 15. Adding 15. 45 plus 15 plus 15. So this one isn't geometric, it's arithmetic. So it is not geometric. It is not multiplying by the same thing over and over. It is arithmetic. Now, its common difference would be 15, but it doesn't have a common ratio because it's not geometric. And just like with our arithmetic sequences that we learned yesterday, we do have some formulas that we need to go over. We've got our recursive formula and our explicit formula. Remember, recursive is always based on the term in front of it. Explicit is always based on the term that it is. Is it the 10th term? Is it the 100th term? So for our recursive formula for geometric, the next term is equal to the previous term times the common ratio. So we need to make sure we know what everything stands for. A sub n is equal to any term in the sequence. A n minus 1 is always the previous term. R is our common ratio. What are we multiplying by? Again, it can be a whole number or it can be a fraction. And then don't forget, A1 is always the first term. And N is the term in the sequence. Is it the 8th term? Is it the 9th term? Is it the 20th term? N always tells us which term we're talking about. So our explicit formula says any term is equal to the first term times the common ratio to the n minus 1 power. Okay, so we need to make sure that we know how to use these formulas. So let's take a look at some examples. All right, write the recursive and explicit formula for this geometric sequence. So first we need to make sure it is geometric. And it is. It's the example we had before. We were multiplying by 3 each time. So we know that R is equal to 3. Other things we know. We know the first term. First term is equal to 5. All right, and so it is geometric. So if we think about our formulas, we have a recursive and an explicit. Let's do our recursive formula first. We said that the recursive formula is any term is equal to the previous term times the common ratio. And the common ratio in this case is 3. So any term is equal to the previous term times 3. Easy peasy. That's the recursive formula. Doesn't help us figure out very well if we're looking for the 100th term, because we would have to do it 99 times. However, it does give us the formula. Let's go over to the explicit formula. Explicit. And our formula for the explicit said that any term is equal to the first term. So a sub 1, that was 5, times the common ratio, which was 3, to the n minus 1 power. Now, this is the explicit formula. I could use this to find the 100th term. You know, let's find the 4th term, just because it's a smaller number, okay? Find the 4th term. Here's what I need to make sure you remember, your order of operations. I can never, ever multiply these two numbers, all right? Order of operations tells me I have to do the exponent first. So I have to do 3 to the n minus 1 power before I can even multiply it times 5. So I've got to make sure that I follow my order of operations. If I want to find the 4th term, I would have to do 5 times 3. Let's see, what is 4 minus 1? It is 3. So 3 to the 3rd power would be 27. Now I can do 27 times 5. 27 times 5 is now 135, which, if you check, that was in fact our 4th term. All right? So you want to make sure that you follow order of operations. Never, ever, ever avoid the temptation. Don't multiply those two numbers. All right? Now, just like with arithmetic sequences, we learned that to find a missing term in between two numbers in the sequence, that we would have to find the arithmetic mean, add them, and divide by 2. However, with geometric sequences, it doesn't work that way because we're not adding, we're multiplying. So, how do we find the geometric mean? How do we find that missing term between two terms in the sequence? So here's our definition of geometric mean. The geometric mean is equal to the square root of the product of those two numbers. Just like when we were adding, we added the two numbers and then divided by 2. Since we're multiplying this time, we're going to have to multiply those two numbers, and then we're going to have to take the square root. So when you're trying to find the geometric mean between two numbers, if I have 12 something and then 3 dot 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 dot, we've got the following sequence, and we want to find that missing term in between. All right, in order for me to find that, I would have to do the geometric mean, and the geometric mean tells me I have to take the square root of 12 times 3. 12 times 3 would be 36, and the square root of 36 would in fact be 6. And I took the positive because a negative number here didn't make a lot of sense. So 6 would be my term in the middle, and that is geometric mean.